Hello guys, today in this video I will be discussing about the rotten oranges problem. So given question is like this: you have given a n into m matrix and in that values vary from 0 to 2, and where 0 represent an empty cell, 1 represent the fresh orange and 2 represent the rotten oranges, and you can move only in 4 direction: left, right, top and bottom direction. At the end, if you are not able to make all the oranges rotten in the given matrix, then you will have to return -1. What this last statement means for this case, as you can see, this orange is surrounded by an empty cell, so this orange cannot be made rotten because this is surrounded by empty cell. No oranges can be made rotten if it is not in the adjacent cell of the rotten oranges. So this is no rotten oranges can reach to this orange, so it cannot be made rotten. So in that case we will have to return -1. So what are the approaches we are going to see here? So if you will closely see the question, then it is first it will look like a minimization problem. You have to give minimum, but when you will deeply check this problem, then you will realize that this minimization cannot be obtained by a single path or something. For example, in the previous problem, in many DP problems, you will be following one path and then you will following other path, and then you will be comparing these two paths and finding which one is minimum or which one is maximum, whatever it is that you were returning. But in this case, it is like you are on some construction site and you have n number of laborers and you were asked to complete some task in minimum days. You cannot do something like in today you will use a labor, tomorrow you will use B labor, and day after tomorrow you will use C labor. This you cannot do because here you think very much clear that if I have to minimize the time, then I have to use the effort of all the laborers who are present to you. So and every day, it's not like today or tomorrow, every day you have to use the efforts of all the laborers. Same is the problem here. If you are given an X, Y and Z rotten oranges and you are asked to make the matrix oranges all rotten, then what you will do, you will use the effort of all the oranges here to make all them whole matrix as a rotten orange. So the thing is, here you will see a issue of parallelism. So when this parallelism comes, then it is clear that we have to somehow, whatever approach you are going to use, somehow you are going to use something like in which you will use take the effort of all the available solution simultaneously, input simultaneously. So in a parallel way you will have to use it. So how in this problem, how we are going to approach? So in this problem we will be using Q. So how Q will make us to attend this parallelism is, initial setup we will push all the rotten oranges into the queue. Whatever oranges we have, that we will push into the queue. For example, we have right now we have 5 oranges, so we will push the indexes of the 5 oranges, as well as we will count the number of 1 also in the initial setup. Also, as initial setup itself we will count the number of 1. If we will count the number of 1, then it will be very easy for us to return the result, that whether you are able to accomplish this thing, are you able to make whole matrix as a rotten orange or not. If not, then you will have to return -1. Then again you will have to iterate through whole matrix and check whether you have done or not. That will be a time complexity of n square. Rather you can achieve it through O of 1. That is why it's better to count the number of ones in the initial step itself. So how are we going to implement this? We will see over here. For example, given a queue here, we have this queue is with initial setup. So we have pushed all the oranges in the rotten oranges in the queue. So let's start with 0 4 index. So in the 0 4 index, we will pop out this 0 4. When we will pop out this 0 4, we will see that this 0 4 is surrounded by an empty orange cell. So if it is surrounded by empty cell, it is not going to impact anything. So it's gone, no use. Then comes 1 into 1. 1 into 1 will come out, and it will check its left, right, and top and bottom. And you can see here it's all four. We can make it rotten, right? And whatever we are making it rotten, we will push it into the all its adjacent or adjacent cell into the queue, so that next time those oranges will be impacting the other oranges in the matrix. So here you will push 1 1 comma 0, then you will push 0 comma 1, then you will push 1 comma 2, and then you will push 2 comma 1. These four indexes will be pushed into the queue. And while you are pushing it, you have to make sure that you are making those indexes as 2, because now these are rotten oranges, so that when the other rotten oranges are interacting with this matrix positions, they should come to know that okay, now this position is rotten. If you will not change that, then the uh, other rotten oranges will consider it as an unrotten, and it will be considered into its time. So it will be a never ending process. Loop will never end. So similarly, you will check for 2 4, then 3 0, and 4 4. 4 4 is again it's a logged one, so it will not impact anything. Then comes the very important thing is -1. Why we are doing -1? At the end, when you will pop out -1, then you will count the number of, or not count, you say time taken, because all this operation will happen in 1 minute or 1 unit of time, because all oranges are working simultaneously. Then after this one, whatever operations will happen, that will happen in second unit of time, right? So when you will encounter this -1, then again you push -1 here, and again when you will encounter this -1, again you will push -1 and check and pop other elements and then do operation and then push -1. So let's see the pseudocode implementation of this problem. So first I said we will be declaring a queue, right? So let's declare a queue. And this queue will be of array list. I'm using the syntax of Java. You can use relevant syntax of your preferred language. And then sorry for my handwriting, but yeah. Okay, so this way you will introduce, because you will be storing indexes of row and column. Either you use this way, or you can use define two queue, like queue row and queue column. In this way also you can use whatever suits you. You can modify. This is not an very important steps. You can modify it as based on your needs. Then we will declare here count of 1 equals to 0, and then we will run the loops from 0 to n. And then here comes the important steps. If a I'm assuming that given input is a, given matrix equals to a, an array list. Okay, a equals to 2, and then what you will be doing, you will be forming an array list. You will form an array list over here, and then let's suppose you give it as temporarily. I'm not writing the whole syntax here. And then you will be pushing the row and column. And then you will pushing this array list into the queue. Okay, this is done. And now comes if a dot get I dot, we are counting here the number of 1 equals to 1, then count underscore 1 plus plus, right? We will do this. This is the initial setup. Initial setup is done, but one thing is pending over here, and that is -1. Then again you will declare 1 here, suppose temp1, and then you will do temp1, same thing what you have done here, same you will do over here. Okay, same thing you will do over here, and you will add this. Okay, now comes the iteration part of the queue. So we will declare here time taken equals to 0, and then we will see here while queue is not empty, till then we will perform this operation. Then first what we will check in this queue, first we will have to pop this queue. For queue it is remove, so this one, and then better you separate it, because many places you are going to use this variable ij. If you will keep it in the same array list, then it will be very long and very clumsy code it will become. So make it small. So I have made it inj. So now I will check it. Check what? If I have pushed it, now I have popped it, now I will pop, and what I will do, I will see all its adjacent indexes, right? If this is, but before that I will check if queue sorry, not q, I equals to j equals to -1, then what I will do, I have to add, first I will have to increment our time taken, then time taken will be plus plus, and I have to append -1 also again. But for that we should be sure that array is not, sorry, queue is not empty, because if we will append -1 in the empty queue, then what will happen, it will be an infinite loop. So we will check here, q dot is empty, then we will simply append q dot, and what is the temp variable we have declared, temp1 for -1, so we will use that one itself here, temp1, right, and go, continue, do not do anything here. Okay, so this will be things we will be doing, and then for the next step we will be comparing all the indexes. So what the comparison we will be making, we will be making if I is greater than equals to 0, then we will be popping. I'll just write one code for one, other four you can write in the same way, just it is an if condition. I will give you the whole code. I have the written the code below. I will give you that complete, but for just to explain you, I will write one example for you. So in this case, if I -1 is greater than equals to 0, then I will add that to the queue. So to add that to the queue, I will simply copy that code here. Sorry, I will simply copy this code, paste it over here. Okay, so this operation you will do, and one more thing what you will do here is, here you will make it to I -1, sorry, make it rotten. Okay, hope you have understood this step. What we are doing, we are adding this index to the queue. After popping out, we are adding these indexes to the queue. I have shown you this one. Rest all you can add similarly for the others based on the conditions, and then you will be making that index to I mean you are making it rotten. So when you will make it rotten, in the next step, when the other rotten oranges will be handling, they will consider it as rotten and it will move ahead. It will not do anything, right? So now I will show you the actual code, and you can And if you have understood the above steps, I don't think that my actual code will be needed for you, but still if you need, in case, you can, I will just scroll it down, you can pause and write it down or take the screenshot. So this one I was saying, you will be checking over here if count 1 is greater than 0, then you will return -1 here. And where we are handling it, we are handling it inside that after setting you will decrease the -1, because now that you have made that orange rotten, so that I mean good oranges will become now rotten orange. So in this way you can be handling it in all the 4 cases. You will be adding this, and then in the end you will be checking that. Hope you have understood this problem. Thank you for watching this video.